So I'm going to get started a little bit late. Sorry about that. Actually, let me start my timer so I know how long I'm going. All right. So I'm Zachary Berry. I'm here to talk about the web audio and web MIDI APIs, specifically the fact that you can actually do this in JavaScript, build a synthesizer. So I'll go ahead and get started. So I'm going to, basically this presentation is going to take you step by step, building upon what you learned on the first step to kind of take it forward, and then at the end we'll kind of have something minimal to work with, and then I can show you some examples going further forward. So I'm just going to click this button. Hopefully it's not going to blast everyone's eardrums. Okay, so that's not very musical, but that's generating sound with JavaScript. That's not playing back a sample. So how do you do that? This is how you do that. So this is the code that I use to build that. All we're doing is we're using this thing called audio context and an oscillator node. And these are provided to you by the Web Audio API, which is currently supported in everything except IE. However, no surprise there. However, I believe the next version of IE will have that built in. At least that's what they say on their blog. That's what they're promising. So what you do is you start off, you create a new audio context. That's just what you have to do. That's kind of the realm that all of these nodes play in. Then you use that to create an oscillator node. And then you connect those two together, which looks like this down here. So we have the oscillator node, which is what makes the sound. Going to the desktop, that's what actually puts the sound out to your speakers on your computer. And then for the oscillator, we turn, and then after 2 seconds, we stop it. So then what is an oscillator? If you were to look at it, it's kind of like this. This is that sine wave that you heard. It's just a periodic waveform. And then specifically this sine wave kind of sounds, it's not very interesting. But you get several other options with the oscillator node. This is built in. So you can do sine wave, square wave, triangle wave, and sawtooth wave. For those of you that have dabbled with electronic music production, those are kind of fundamental. I mean, they are fundamental in other types of music, but these kind of pure waveforms are usually what you build upon to generate sounds. I think I'm going to turn this down just a tiny bit because I'm worried it's going to. Let's do that. Okay. So here I've built it so that I can now stop the sound. And I can also. Yeah, it's too loud. Try that again. Okay, it's the same volume. Well, I won't do that. But yeah, so then you can then with this you can select the different waveforms, play them, and stop them. So building on what we did last time, now we have new functions that I've written: play sound and stop sound, and then just simple code to wire up the buttons to make it run those functions. Nothing crazy going on there. But so then play sound will now set the type of the oscillator that select that I had. So the values of that select are just the string, sawtooth, wave, square. You can also do custom ones, but I'm not really going to talk about that in this one, in this talk. And then stop, we stop it, and then we also go ahead and disconnect, and we create a new oscillator. So each time we're hitting play sound, we make a new oscillator, and then we stop it, and we kind of get rid of it. All right, step 3, now we're introducing a new type of, which is this gain node. So what this does is it allows us to modify the volume. So stop that. How that works is now here we're introducing this gain node. Same thing with before with the oscillator. We just do audio context.create gain. And then we wire it up. So the way that this works is you just connect these almost like if you had like a effects box or like a guitar or something, you're kind of plug it into these various modules to create this. So the oscillator connects to gain node connects to destination. And then we set the slider, so we listen to the slider that I was dragging, and when we get that event in, we set the gain value to that slider. And then I think that's it, yeah. All right, so now we're building, doing a little bit more interactivity. So this is a very simple theremin. So over here, it's going to be a low frequencies, and then it's going to increase. And then if I go down, it will get louder and get quieter as I go up. So we're changing the pitch here. Musically, it's not very interesting, but it's demonstrating what we can do with pitch. So here on mouse move, what I'm doing is I'm getting the percentage of where my mouse is on the screen, where 1 will be all the way over to the bottom right of the screen, 0, 0 up here. And then I'm setting the frequency value and the gain known value to frequency to the X position and gain to the Y position. All right, so next is actually introducing notes. So what I've done here is for each of these essentially divs is I have a data attribute on all these. It just gives it a frequency. So this one I have set to 220, I have set to 440, and everywhere in between. And I'm just piping that frequency into the method to set the frequency. Now, where did I come up with 440 and 220? Those are just kind of known values that, like, if you ever study music, that tends to be the frequencies that, at least on this like 12-note scale, people have settled on. So the way that works, on mouse down, so when I'm clicking on these buttons, I see here, let's see. So I'm getting that frequency value, and I'm just piping that frequency value to play note here. And then I'm just setting the frequency onto my oscillator. All right, next is envelopes. So you'll hear it here. Instead of just having the sound come all the way on and then the sound come all the way off when I release it, now we're just, if I hit it, it'll play for a little bit and then kind of taper off. And so to do that, I've changed this up. Now, basically, I start the oscillator at the beginning. So as soon as my code is run, that oscillator is generating sound, but I have it connected to my volume, and I have the volume all the way turned off. And so when I play the note, what I'm going to do is I'm going to turn the volume up on the note, and then turn it back down. Or sorry, turn the volume up to let the sound come through, and then turn it back down. And if you look up the web audio APIs, you'll see these functions. But we have set value at time and set target at time. So set value is specifically for the oscillator, and set target at time is specifically for the gain node. But all these are doing is there's, well, at least for set target at time, it's saying, okay, right now I want you, let's see, yeah, so I set the volume all the way up, and then I say, in 0.2 units of time, I want you to set it down to 0. And you see these current time values. That's provided to you on the audio context so that you can get the current time, and you can do various math with that. So you can do like current time plus 2 for like, I think that's 2 seconds. And yeah. So that's a quick run through of the web audio APIs. Now I'm going to switch gears here, and I didn't connect up something. Yes. So I have this board here. I'm going to refresh this just in case. So this slide is just saying, so MIDI is a standard that was developed in 1983. What it lets you do is it lets synthesizers communicate with each other and other electronic instruments. So all MIDI really is just a bunch of message passing. So if I hit a note, it's going to say, okay, you hit the note on at this point in time, and then you release the note, and I'll send a note off message at this point in time. And that was kind of a revolution back then when everything was hard to get it to speak together. And then in 2013 is when the Web MIDI API started working for Chrome Canary. Still 1.0, because they nailed it the first time. and it's basically still the same spec from 1983. There's a slight difference, just if you're confused about MIDI files. That's still just note information, but there's not really any sound per se with those, except that you typically would play that, and then they'd have other software that like interprets that into sound. But here I'm specifically talking just about like pure note data, no musical instrument information, or no audio, I should say. So hopefully this works. Yes. Okay. So here I'm pressing on the keyboard, and you can see basically I'm just outputting the MIDI messages that I'm getting. And I have this knob here, and if I turn it, you should kind of see it change values, going from 0 over there to 127, which tends to be the max for the MIDI. So take a little bit of time on this slide. The way this works is you request MIDI access. You definitely want to if request MIDI access, because more likely than not, this won't exist. It won't from Canary right now, except it can work in Chrome if you turn on the experimental web MIDI flag. So you have to go to About Flags and turn it on. Then you have, this is a promise. So you say request MIDI access, and then if I get it, call on MIDI init. If I don't, call on MIDI reject. So I'm not really interested if I don't get it, but if I do, then I get this MIDI access object, which has changed since I last played with this. But basically what I can get is I can get an iterator back of the devices that I have hooked up to my machine. And then I can cycle through those. This is a ECMAScript 6 concept. But then I can then use the onMIDI message function and give it an event listener. Excuse me. So what I'm essentially doing in this code is I'm going through, finding all of the things I have hooked up to my machine, and saying, if you get a MIDI message, I want you to call this function here. And then this function gets the event object, which essentially just has this data and data 2 attributes on them. And what I'm doing right now is I'm just putting them to that output, to that text area, just so you can see it. So I want to talk a little bit about that MIDI message. Now remember, this is from '83. So everything is very minimal. It's all in binary, but it's not too difficult to figure out. You have it split up into 3 parts, at least for this specific message. And here it is broken down. So the first part of this status byte, this basically means note off. If you want to know how I know that, it's all here in the original spec. So that's the note off event here. You can see there's a bunch of different stuff, but typically this first area is what's most interesting, and everything else kind of gets a little bit more elaborate. But so yeah, we have note off. We have channel 1. So the way MIDI works is that there's potentially 16 channels, but that's kind of more of a legacy thing. At least for this, we don't really need to worry about that. And then we have the second data byte tells us which note that we hit, and the MIDI specification is mapped each note to a number, 60 being middle C. And then finally we have velocity, which is how hard I hit the note. And if it's 127, that's 100% velocity. So this should work now. Let me move this off. So yeah, what I'm doing now is I'm listening to the MIDI message, and then I'm sending it to a function which is converting the note number, this is like note 45, note 47. It's converting that note number into the frequency it should be, and then sending that frequency to the oscillator node, which is then generating the sound. So I left out some of the more uninteresting code, but the crux of it is this handle MIDI message event. So what I'm doing up here is I'm looking at that first information, which if you remember is this step. I'm basically trying to just get out this first part of it to determine what kind of note or what type of message it is. So to do that, I need to use what I don't normally use in JavaScript, but some of the bitwise operators, which I don't really want to cover per se in this presentation, but basically I'm masking it so that I can just pull out that first part of that number. And then I can check and see if it's this, and I know that's a note on event. If it's this, then I know it's a note off event. This is hex, but it's the same thing as you were seeing earlier. Then if I get a note on event, I pass it the next part of my data block, which happens to be the note number. And so what I'm doing here is I'm getting the frequency, and then I'm setting the frequency to what it should be based on that note number, which is this crazy equation here, which I didn't figure out. I just found it online, and it seems to work. And then I just have a function to get the note number and then make the and then get the element so I can make the pretty effects. But it's not that interesting. All right. So last is filters. So what I'm doing here is I've added 2 more oscillators to the sound. I'll talk about that in a little bit. But I'm also using this knob here. So here, let me go down. Let me go up. So down here, the filter's all the way down, and it's pretty muffled. But if I go up, they'll get brighter and brighter. And I'm also doing some manipulation. I'm setting the CSS to that knob, to the Chrome logo, based on this knob here. So here are the 3 oscillators that I have created, and then I'm setting their types here, and then I'm detuning them here. So what I'm doing is I have the second oscillator kind of pitched up a little bit, and the third one pitched way down, so it kind of beefens up the sound. And then I have a filter node here, which is called create by quad filter. That's just something I looked up. I'm not, that knowledgeable as far as like the technology behind the filters, but you can make one of those filter nodes, and I'm just doing basic connecting. So 3 oscillators to this filter, and that filter's then goes to it. And then I'm starting the oscillators, and then when I'm hitting the key, it then sets it sets the frequency of those 3 oscillators all at the same time. And then I've added to my handle MIDI message event this new thing that's looking for the filter now. So this happens to be the message I need to listen to that filter. Basically, it's a control change. So that's any sort of dial, like a sustain pedal, a dial, anything like that. Right now, I'm just listening to everything, and I only have this one knob. But theoretically, you could listen to a bunch of different things if you have like a more advanced controller. And then, so I'm just setting the filter based on a percentage from 0 to 1. And then I set the frequency of my filter from 0 to 1 times the maximum frequency, which happens to be, I have it set to 6,000. It seemed to work okay. I think that this ends up being linear, and you want something more exponential, but I'm not going to get into that for this presentation. So that covers as far as what I wanted to do as far as building the synthesizer. But I do want to show you some of these examples. So Chris Wilson is the guy that's done a lot of work here. I think he's the one that mostly wrote the spec and has done a lot of the examples as well. So this is where you can end up if you're going very far with it. So he's built like a whole thing. He's got all of these knobs, and I forget this. Yeah, turns that. You can't really hear it, but yeah. So then he has a whole section of filters, of envelopes to kind of shape the sound, waveforms, and I can detune them, stuff like that. So that's like kind of taking what I've built to its logical end. And then go back here. You can process a lot of audio. Which is kind of interesting. I don't really want to embarrass myself like a non-live audio here, but so this is a vocoder, which you might have heard in like several 80s songs or electro songs, but you can kind of like robot your voice, and I can tweak these. And a lot of things I didn't cover, so there's like audio analyzing nodes, so you can do that kind of visualization that you see here in this example. And yeah, if I did live input, it would ask me for my mic, and I could talk into it. That would work. You can also record audio, so you can use some of this stuff to have someone speak into a microphone, and then it produces out a WAV file, all without needing anything but a browser. There's tons more demos of this on web audio demos. Lots of tutorials that I use to kind of get this information together. MDN is always a really good resource for all of this. Specifically, this slide share was really helpful because the last time that I played with this, it's changed since then. So none of the stuff that I had working worked at all. But this kind of covered, this is the only source I was able to find to kind of figure out how to really get the MIDI initialization step to work. Oh, that didn't open up a new window. And again, link to just the MIDI spec, so that just covers all the messages and everything. And that's it. So, thank you. Any questions on this? Yes. You. Yeah.
So, can you run all this locally, or do you need to be like making calls to something on the internet?
This is all local. Yeah. Everything. Like the only thing I'm like using like a CDN to get like the, the code. Just displaying the code. All the MIDI stuff, all the audio stuff, that's all client-side JavaScript. Anyone else? Yes? A song? I was going to learn how to play something, and then I ran out of time. I don't know if you really want to hear anything that I'm going to be able to play. Oh, it's actually playing the other tab. So one thing is like this is pretty finicky sometimes, at least it used to be. It's a lot better now. Before I would basically start up Chrome Canary, play with it for a while, and then close Chrome Canary and open it back up again. Because otherwise it would just stop working. But now for the most part it's pretty stable, but I think like here you can see the little Chrome message or audio thing saying that that's playing. Yeah.
Does your code support like multiple notes at the same time?
I'm sorry, multiple what?
Multiple notes at the same time, like you play chord?
So yeah, that's an interesting question. It doesn't do multiple notes. Everything that I have is just one note at a time. So if you wanted to do multiple notes, essentially what you would do is what you would do when they started making polyphonic synthesizers. So you have a bank of oscillators, and then when you play a note, as you keep playing notes, you round robin those oscillators, so that maybe you have like since it's code, I can make as many as I want. So let's say I make like 50 of these. Every time I play a note, it would just then go to the next one, go to the next one, so that the first time I play can kind of taper off. Then I can play something else, and they'll both be at the same time.
Oh, so you
but
can't just put them all into the same node and have it figure it out. You have to like align each one to its own sort of thing.
Yeah, I think because basically every oscillator you can only give it one frequency,
right.
And so you play two notes, that's two frequencies, so you need two oscillators. At least that's what I think.
That makes sense.
Anyone else? Yeah.
Yeah. So if I want to make the next hot hit, I can combine all these features together pretty much.
Yes. I think you could. I mean, like, what's interesting is a lot of the sounds that you produce, at least initially when you get started, if you wanted to make a chiptune band, would work pretty well, because it's all just like raw oscillators, and those video game systems that people now use to make music are all those raw waveforms. So, sure, why not?
So can you send MIDI messages out to hardware?
I believe you can. I saw that like when I was playing around with this, like the MIDI objects I get back from my instrument, it gave me like inputs and outputs, but I didn't get a chance to mess with that. So I'm not entirely sure, to be honest. Anyone else? All right. Thank you, guys.